Hey everyone, we are doing part two video of the stairway or staircase problem, I guess. If you haven't seen the previous video, you should probably watch that first, or else this video might not make much sense. I'll try to remember to put a description, a link in the description. Quick recap of what happened last time. So we had this problem, given a staircase with end steps, and you can climb some set of moves. We did the follow-up version, so it's like here it says 1 or 2, but in the follow-up version it's an arbitrary set of moves. List all the possible unique ways you can climb the stairs. So for n equals 4 and for the set of moves being 1 or 2, this was the answer. We did it in Rust, and I didn't know Rust at the time. I still don't know Rust that well, but we struggled through it, and we had a solution that worked. I believe here, this is what we had. We wrote this recursive function. So let's look at the main function first. Here's where we call our solution. We pass in the set moves 1, 2, the total number of steps in the stairway 4, and then we just print out the solution. And it's it was like, you know, the quote-unquote obvious recursive solution where you pick some move from your possible set of moves, and then you say, okay, so now, like, let's say it was 4, and then I took a step of size 1, so now there's 3 steps left, and how many ways do I have to solve that, and then so on. Towards the end of that video from last time, I said, let's try to memoize it, right? Because we're recomputing solutions, we're performing computations that we've already performed, and so we were trying to figure out how to optimize it. And I said, well, we could try to memoize a function. And then I ran into like a lot of problems with that. Like, I was running into all sorts of problems with the borrow checker, which borrow checker is a concept in Rust which is similar to type checking, but instead of checking that the types are what they need to be, it checks that the borrowing rules are what they need to be. And because I didn't know Rust very well at all back then, I could not figure out how to make that work. So I spent the last week or so, reading the official Rust book. I have a link here, I think. No, this is the API, but there's a Rust. Actually, here it is. doc.rustlang.org/book. So I've been reading through the Rust book. I'm in chapter 15 now out of 20. I asked questions on Reddit, on Stack Overflow, on the official Discord channel. So just, learning Rust as quickly as possible so that I could solve this follow-up problem of memoizing. And it turned out to be way, it's way more harder than I expected it to be. I was surprised. But I think we can do it now. I think we know, or I know enough Rust to solve the problem to do the memoized version. So let's try to. That's what this video is going to be about. I'm going to try to actually implement it now. Okay, so first of all, let's run the old solution. I think here it is. So I'm going to compile stairs.rs. That's this file here, stairs.rs, and I'm going to execute it. Yeah, so here's where we were at the last video. We had a solution that appears to work and prints out the correct solution. To demonstrate the problem, I'm going to add a print statement here. Print line. I have this called with. Oops. And I think this is how you do a placeholder variable for formatting your print line. So I'm going to print the value of n. Set of moves stays constant throughout the whole function. We keep passing the same set of moves each time, but n, which is the number of steps remaining, changes with each call. Okay, so with this change, I'm going to recompile now. And then, so here's the debugging lines that we just added. And here's where you can see the problem that we're trying to solve here, right? Like, this function was called with the same input multiple times. Like, it was called with the input 1 3 times and called with input 2 twice. So our goal is to perform a memoized version of this function, meaning we're going to have some sort of cache where if you call this with the same inputs, rather than reperforming the computation, it just looks up the value in the cache and returns that. So that's the goal of this video, and we're going to go. Hopefully we achieve that goal. First, a little bit of cleanup. Like, now that I understood more things about Rust, I want to make some changes to some cleanup changes first. And so one of them is this here. So what this function does is it returns a vector of references to usize. Usize is basically an integer. And I don't think this should be a reference anymore. I think we should actually return the integers themselves. It basically says when dereferencing, I believe. I mean, I'm not sure exactly what the how this Rust code compiles down to assembly level, but it's just like semantically. I think it makes more sense to say that these are integers rather than references to integers. This data structure, by the way, is the list of all possible solutions. Let me go back here. So it's a vec is like an array. It's a vector, right? That can expand. So it's an array or a vector of integers. So it's this. Here's a vector of integers. Here's one of those vectors of integers. And right now these are references to integers that get dereferenced, I guess, when we print them out. But really, I think they should be integers rather than references to integers. So we're going to change that. And I think that's going to cause... does this just compile now? Let's see. No, it doesn't. Right, okay, so... redval.push here. Let's see, sorry. This is line 31. That's over here. So possible move is actually... Maybe I'll rename this also to make it clear. It's actually a reference. These are references to integers rather than integers themselves. So with that renaming, I actually want to dereference to actually push in the integer. And actually, maybe I can do it once here where I can say that possible move. I take my possible move reference and I'm just going to dereference it. And that's what I'm going to put into the vector that I returned. So it's line 40, same concept here. This push wants to receive a usize or an integer, but it found a reference instead. Here it is, line 40. So I'm just going to change this, oops, to possible move instead of possible move ref. And this should compile, I guess. Yeah. But there's a few more things. So here I'm comparing a reference, this possible move reference, to our reference n. But I think that's also a little bit silly, and I would rather just compare the integer value of the possible move to the n that we receive here. And similarly over here. This I'm surprised it works. I feel like rather than subtracting from the reference to the integer, I should just subtract from the integer. Let's check if this still compiles and still works. No, it doesn't. Oh, did I make a typo? I've made a typo. Possible move with an L here. So let me fix that typo. Okay, this still works. Where else am I using possible ref? Just here, basically. Okay. So yeah, I think with that, that's enough. That's the only cleanup I really want to do before I dove into the cache issue. Okay, so it's setting up the cache for memoization is actually pretty... I can't do it reliably. I was gonna say it's error prone. Let me get rid of this comment because that was just for the big old analysis we did last time, but it's no longer relevant. It's pretty error prone. I don't know that I can do it correctly on my first try, so we're gonna do it very, very slowly, like one step at a time. And so the first step is to get the right import, and I don't know the imports by heart, but I think if I go to here, I can find, yeah, here, this is how I import hash map, bring it into scope. So now I can reference hash map, and this is some commented out code I had from last time, but it's mostly correct. The idea is I want to actually, no, it's not correct, but well, it's fine. Like this will be a good way to test that the import works. So I'm creating a mutable local variable of type hash map. And Yeah, let me just make sure the parameters right match up, because here I had the ampersand again to say it's a reference, but no, this looks correct. So let's compile this and make sure this still works. And yeah, it works. There are some warnings because it says we have unused variables, but that's fine. Okay, so let me think here. What I wanted to do, I think the solution I eventually got working, because I struggle with this like a lot with Reddit questions and Stack Overflow questions of trying to get this working in different ways. I believe what I ended up doing was creating a struct that owns both the cache and the set of moves. And the idea is like we're gonna have a cache that just it's indexed by n here, like which the number of steps remaining in the staircase. But we want to treat set of moves as basically constant. Like you choose a set of moves at the beginning of your program, and we're just going to use that same set of moves is used throughout this computation thing. So I think what I want to do is I want to create a struct, and I guess I call it cache stairs or something like that. And then we're going to say this houses a set of moves. And it's also going to house the cache, which has this type here. So we're just declaring a struct with two fields, one called set move, one called cache. Let's just make sure that compiles. It doesn't expect a lifetime parameter. Oh yes, the lifetime parameter. So when you have references to things, in some cases, I'm not sure. I guess in all cases. Let me do the explanation one step at a time. So when you have a reference to something, this is basically a pointer to some region in memory, right? And you have to convince the borrow checker or the type checker, the Rust compiler, basically, that as long as this field is accessible by some part of the code, or as long as the reference is accessible, the region of memory that points to is valid. It's been initialized, it's been allocated, or whatever. So to do that, there's this mechanism called lifetimes. Like it wants to know how long does this reference last, and does it last at least as long, or sorry, does it last no longer than the lifetime of the thing that it's referencing, right? Because if the object that's referencing dies, quote unquote, or goes out of scope, the reference itself had better have already died, because we want to prevent the situation where you can reference variables that are, or memory locations that are no longer allocated. So to do that, we just choose it's like a generics in a sense that you use a name to represent the lifetime. We're going to call this one A. That's the convention, it seems. And then I have to say that this struct has a generic parameter of A as a lifetime. The apostrophe means that that we're talking about lifetime, as opposed to a generic type like T. Like if you're familiar with Java or other languages like that, we could say this is an array of T who's with a lifetime of A, basically. But so you don't put an apostrophe in that case. But if you want to have a lifetime generic variable, you need the apostrophe. That's the syntax, right? So let's make sure this compiles now. Okay, it looks like this compiles. So now let me create an instance of this. Actually, no, before I do that, I want to create a constructor for this guy. So here's my struct, and then I want to create, this is sort of like doing an object, like a class in a sense, if you were doing an object-oriented program. I haven't got to the chapters on object-oriented programming in Rust, but it sounds like Rust isn't exactly object-oriented. It has some object-oriented features, but there's no concept of class, for example, as far as I know. Like there's structs, and then there's functions that are related to the struct, which you can think of as methods. So the idea here is I'm providing an implementation for cache stairs, and one of the implementations I'm going to do is a function called new. And what it's going to do is it's going to return a cache stairs. By the way, you're going to hear my phone beep every now and then in the background. I'm assuming it's being captured on the stream, and it's because I'm currently on call for work, so if something bad happens and I get paged, I might have to stop this video early or pause it or something like that while I go deal with the emergency. So So I apologize for the little beeping here and then, but I can't mute my phone right now because I'm on call. So why do we want a constructor? Because I want someone to be able to, I want the caller to be able to pass in the set of moves here. I think I'm gonna delete this for now, but I'm probably gonna have to re-add it in a moment. So what the constructor is going to do is it's just gonna create a new instance of cache stairs. And I call this constructor, but it's like if you're coming from the Java world, this is more like a factory method, a static factory method, right? Just a quick preview. So this new method is like a static method in the sense that you don't need an instance of cache stairs to invoke it. What instance methods look like, and I'll call it foo, for example, is like this. It's a method that takes a reference to self, like meaning an instance, and then you can do stuff with that self. But so that's what instance methods look like. So these are like static methods in the sense of which the constructor or the factory static factory method is one of them. So I'm creating a new instance of cache stairs. I'm going to initialize set of moves to be this thing that's passed in. So it definitely needs to be a reference. So you give me a reference to a set of moves, which is an array of integers, and I'm just going to store that in here. And I also have to initialize this field cache. And I'm just gonna do this here, except I have to use colon instead of equals when I'm creating an instance of a struct like this, and no semicolon over here. So I believe this won't compile because I think it's gonna tell me I'm gonna need to specify some of the lifetimes here, but let's just check that to be sure. Expected lifetime parameter, yeah, okay. So I think what you have to do is you're creating a new generic type parameter here. So this is declaring the generic types, and then I'm using it here. I'm saying in this implementation, there is going to be some lifetime called A, and cache stairs needs to live at least as long as A, and so does this guy, so does this reference. But I'm going to leave this out for now because I want to see the compile error to confirm this. Oh, was I wrong? Apparently I was wrong. You don't need apostrophe A here. Or maybe it infers it. Maybe I forgot to mention that earlier when I said, when I started talking about lifetimes, I said let me do one step at a time. I said what I had said earlier is it seems like sometimes you need to specify the lifetimes and sometimes you don't. I think what happens, and I don't know for sure, this is speculation, but I believe internally Rust always keeps track of all the lifetimes of all references. So for example, this has a lifetime on it, but in some cases Rust is able to auto infer the lifetime, and so it doesn't make you specify in the same way that sometimes Rust can infer the types of variables, right? Like for example, here we explicitly gave a type. We say red_val is of type vec_usize, but here we have a variable that we declared that we did not specify type. I'm trying to see another example. Here's another example where we didn't specify type. So just like it has type inferences, I guess Rust also has lifetime inferences. So I'm guessing, I'm not sure here, that it was able to infer that the lifetime of this must be apostrophe A. Let me just check. If I explicitly put it, it should still compile, hopefully, yeah. So whether I put it or not, I think we're getting the same results. It's just in this case it was able to infer the lifetime. Okay, so now we have a way to instantiate our class. I'm gonna do it down here. I'm gonna say let cache stairs, and actually, so I meant to call it cached stairs rather than cache stairs. So let me just make sure we rename it everywhere here. So I'm just going to instantiate it, passing in basically the same thing here. And the goal is I'm gonna recreate this. I'm gonna call the old version, and then I'm gonna call the new version, and we're just gonna compare the performance. So let me maybe say here, I'm gonna say, oops, calling version 2 the Memewise version. But for now, let's make sure this compiles. We take baby steps because I'm not at all confident. Yeah, okay, no, that's just a typo. So I missed the D here. But yeah, we're taking baby steps because I'm not at all confident that I can get this right, unless I take baby steps and I know immediately when I've made a mistake somewhere. No, it's telling me use a snake case name. Fine, we can do that. Not a big deal. Okay, So the next step is I want to basically take this function and move it in as a method of cache stairs. So the way we're going to do that in the baby step function, in the baby step manner, is we're just going to put this function here, and then we're going to use the unimplemented macro, so that we don't, because if we didn't do this, Rust would complain that we need to return some value of type vec usize, and we're not doing that right now. But to do this is basically the bottom type, if you guys are familiar with that concept. It's similar to do in Kotlin. It's similar to throwing an exception in Java. It's just a way to avoid having to construct a value of this type and return it to satisfy the compiler. So compile this again, make sure this should be fine, but yep, that worked. Okay, so now this is also a static method, and we want to convert it to an instance method. And so to do that, I'm gonna say this function takes a reference to self, takes a reference to an instance of cache stairs. So this should also compile just fine. Yep. And then what I'm going, now that this is an instance method, what I can do is I can invoke it. I can say cache stairs dot stairs, I believe is what I call it, right? And then I have a bunch of arguments here, set of moves and end. So I'm just we're gonna come back to this in a moment, but just to get it to compile, I'm just gonna do this, and I actually might as well copy and paste this part also. So the idea here is we're printing out the results when we do solution 1, and then we're printing out the results again when we do version 2 of the solution. So when I'm going to compile this, and I think it's going to compile correctly, but I think it's going to fail when we run it, because what's going to happen is we're going to invoke this method, cache stairs.stairs here, which is going to go in here and then hit this line, and then it's going to throw an exception in Java terms. The way Rust calls it is it's going to panic. And hopefully we'll see that error message here. Yeah, so it compiled correctly and now it's running, and it says here thread main panicked at not yet implemented stairs, line 17. Yeah, so far so good. Okay, the next thing I'm going to do is because this is an instance method, now I can reference this field, right? So I don't want the caller to pass in the sub moves anymore. I'm just going to read it from this field here. So I'm going to get rid of this guy. And then that means when I call it down here, where is it? I called it here, I don't pass in this guy. And this should also compile. Baby steps, looks like it's still working. Okay, now for the meat of it, the fun part. So I'm gonna keep this guy, so we know when we get a recursive call, and let's make sure that works. And what we'll see is here it says I was called at 4, 3, 2, 1, and so on. Version 1 works. Now it says I'm going to start version 2. I was called at 4, and then it panics, right? Which is exactly what we expected, because here it is. I was called 4, and then it gets here, and then it panics. The key thing is what we want to see is in this case we don't want to see duplicates. Like we don't want to see I was called with 1 more than once, and we don't want to see I was called with 2 more than once. Each of these values of n should only be invoked once, and the rest we get from the cache. Okay, so what's the first step? The first step is let's try to read the value from the cache to see if we already have a value for it. So this was one of the trickiest parts because well, not right here, but it's going to become tricky in a moment, because we're going to both read and write to the cache, and so we need to do a mutable borrow and an immutable borrow of the cache, and you have to set it up just right to get Rust to believe that what you're doing is safe. So hopefully I'll get it right, or even then if I don't get it wrong, it might be interesting just for us to learn together or observe the problems that come up. So I'm gonna get something out of the cache. I'm gonna call it, here's the cache result, and what I'm gonna do is gonna do cache. I believe it's .get, and then I pass in a reference to n. But let's pass in n for now, and I think this will not compile. And it's gonna say you need to pass a reference instead. Oh right, I need self.cache. Yeah. Not just cache, because it thinks that cache might be a local variable. Self is like the this pointer in Java. It's a reference to to yourself, your own object, your instance, basically. So let's see here. And yeah, so here it's saying the get method on the cache, which implements hash map here. It wants a reference to usize, but I gave it a usize. So I'm going to do a borrow, a so-called borrow. I'm going to get the reference to the parameter here, and that's what we're going to send in. So now I believe it will compile correctly. It'll just get to the point where it panics. Yeah. Okay. So I have a cache result now. The cache result is an optional. So meaning because the value may or may not be in the cache, right? So what I can do is I can say, and my instinct is always to put parentheses around if statements, but in Rust you don't do that. Like down here, as you can see, you don't put the parentheses around the if statement. I'm going to say if this is a sum, like meaning it's not a none. So if it's present, I'm going to do one thing, which is I'm going to unwrap the optional. Basically, I'm going to return it. And I think, let me see here, that this won't compile. Yeah, okay. So there's a little trick in Rust to get the compiler to tell you what the type of something is, and that trick is to assign it to the empty tuple. So I want to know what the type of this is, and to get the compiler to do it, I try to assign this to the empty tuple, and then it'll tell me what the type is via compiler, because it'll say, yeah, it says this is what's on the left hand side, and this is what's on the right hand side, and they don't match. So this is an option to a reference to a vec of usize. When I did unwrap, I'm removing the option part, but I ended up with this, a reference to a vec of usize. But as you can see up here, my function doesn't return a reference; it returns an actual vec of usize, not a reference to vec of usize. So what I need to do, let's try dereferencing it. That's not what I did last time when I got the solution working, but this might work. Let's see. No, it probably won't work. I'll probably say something like you can't do a move of this. Let me. Oh wait, I need to get rid of this guy. Yeah, cannot move out of borrow content. I don't know exactly what that means, but I know moving is basically changing ownership of a variable, and I guess what's happening here is this map. When you put a key in a value, the map takes ownership of the value. Taking ownership basically means that the map is responsible for allocating and deallocating the memory associated with that variable. So it's going to own the vec usize. So meaning it's going to own the memory location for it. And if I dereference it and return that to someone, how do I say it? The caller now has, I guess, an object that might outlive the cache stairs. Like if the cache stairs goes out of scope, it's going to deallocate the memory associated with that value, but I'm still using it somewhere else. So Rust says that's unsafe because like I could dereference like a memory that's been deallocated. So instead, I guess I'm going to have to clone it for now. I'm not happy about cloning it, but according to the Rust book, they say this is a common thing to get over as a Rust beginner, or which is like they say people who are beginners in Rust tend to avoid clone too much. The advice from the Rust book is just do a clone to get your code to compile, and then come back and do the analysis of like if there's a way to avoid the cloning. The clone does like a deep copy basically. So we're just gonna clone this. I believe this will compile. Yes, it does. And then, but we still hit 4 and then the panic. Why do we hit 4 in the panic? Because we hit 4 because the caller in the main method here passes in 4. Where does that happen? Here. And then so we print out this thing, and then we check if 4 is in the cache, but of course it's not a cache because this cache is completely empty. We've never inserted the value into it. So we don't go into this use case, and then we hit this use case, where the code panics because we hit an unimplemented block. Okay, so if we hit here, this means the cache doesn't contain the value we want, so we should compute the value and then put it into the cache. So to compute the value, I'm basically going to copy the code from down here, from implementation 1. But again, I'm going to do it like baby steps, because it's very easy to get into a situation where where at least I get these compile errors that I don't understand anymore, and I don't know how to get out of. So it looks like the first thing we do is we create a vec of vec, an empty vec of vec as our return value, and then it's going to be a mutable local variable. So I'm going to do that, and then we say if the number of steps remaining at n is 0, we return this as our results. We immediately return retval. So let's check that this still compiles. Looks like it does. Okay, good. Otherwise, we're going to go into this for loop. So I'm going to go into this for loop. Set of moves here is we want to read that from our field here, right? Set of moves. So I'm going to reference it like this. Let's check that this compiles. Looks like it does. Okay. And actually, it looks like after the for loop, we just return retval. So maybe I can do that. Let's see. Maybe I can return retval here, and then we won't get a panic at the end. It's just we'll get the wrong results because we haven't implemented this poly yet, right? So let's see that. Yeah. Okay. So what's next in this body? So the next thing is so we have our possible move ref, a reference to possible move, and now we want to dereference it. So that should be fine. I don't think that's gonna be a problem. Otherwise, we have this if statement. And if the statement is true, then we mutate retval, we push some else, we do some other stuff. And I'm gonna put the to-do in that other stuff here. So let's check if this still works. This looks like it's working. Okay. I'm getting these warnings here that say like, this variable is unused. The cache variable basically is unused, but we're going to use it soon. So that's why I don't want to correct that warning yet. But actually, aren't I using the cache variable? Where is this? Line 67. Unused variable cache 67. Where's 67? Oh, down here? Yeah, actually I'm not using this one, so I can get rid of that guy. Let's see here. Okay, so now no more warnings. Okay, it just works. Alright. So this is, now we get to handle this case here. This is copied from here. So this is where we get into dangerous territory. Now I'm going to recursively call myself, and this is where it's very easy to get the borrows wrong. So here I'm not calling this stairs function. I want to call stairs on myself. I don't pass in the set of possible moves. I just pass in the single integer basically, which is how many steps are left. So I think this will probably work. Let's just check that. Yeah, it works. It's just there's a warning that there's unused variable suffixes here, but we will take care of that very shortly. So then we have this if statement that says if it's empty, we'll do nothing. Otherwise, we'll do this thing. And let's get the for loop in there because I think that's relatively safe also. Make sure this still compiles. Looks like it is still compiling. Okay. And then here, we're just going to paste in this poly here. Let me just check here. So what are we doing here? Here we've done a recursive call. We got to get the suffixes. We're going to iterate over each of the suffixes. We're doing a clone here. This is all just copied from the previous one, so it's probably correct, the logic. But we create a clone of the suffixes. Actually, in this case, I probably don't need to create a clone. I'm not sure. The reason I don't need to create a clone is because I can see from the return type here, we're returning a vec usize as opposed to a reference to a vec usize or actually I don't know what other alternatives are, but like, and what that means is that this function, since it's giving us directly this object and not a reference object, it means the caller owns it now. So the caller can do whatever they want. They can mutate it. They can just go crazy with it. And so that means I own here. I'm the caller, right? I'm calling this thing, so I own this. I can make changes to it. I believe that's what that means. But this might still be variable because I think the for loop variables, sorry, are non-mutable by default. So I think this changes it to mutable. Like I'm doing I'm basically signaling to the compiler that I want to get a lock on this. Basically, I want to be the only guy who can mutate it, or rather, I want to be able to mutate it so the compiler ensures that I'm the only one who's mutating it. So let's see if this compiles. It does. Okay. So right now this produces the correct answer, I believe, but it's not actually using the cache, right? We're reading from the cache, but we never actually insert it into the cache. So now this is like the trickiest step of all. So when we hit this line, we're about to return the answer. Rather than immediately return the answer, we want to store the answer into the cache. And so what I'm going to do is I'm going to do self.cache.insert, and I think I pass in n, like the key, right? And then I pass in redval, right, the value that the answer that we computed. And now this is going to fail to compile for a couple of reasons. One of them is that here, what I'm saying here is I need a reference to self, but I indicate that I need a immutable reference to self. This signature implies that stairs is not going to mutate the instance, but we are going to mutate the instance here because we're going to mutate the cache. So that's one reason it's going to fail. The other reason it's going to fail, I can't remember now. I forgot. I was going to say something about redval. Oh, right. Okay. So insert. Let's look at the API doc for insert. Here it is. Insert. So if you look at here, yeah. So insert it's going to mutate the cache. That's what the and mute here means. But notice that this is these have type K and V as opposed to ampersand K and ampersand V, or reference to K, reference to V. What does that mean? That means that this method, oops, sorry, I didn't realize clicking was going to cause it to scroll like that. This method is going to take ownership of the key and ownership of the value. What does that mean? In the case of the key, it doesn't mean much because it's an integer, so its integers are objects that live entirely on the stack. They can live in one memory location, in fact. And so taking ownership is basically copying. Like it's just going to take if I have like the integer 5 or something, it's going to take a copy. It's going to have its own variable that represents the value of the integer 5, and that's fine. But this part, this is an object, or well, I guess a struct in Rust's terms. A structure. This has some memory location, like it points to some data on the heap, and now the cache owns that, meaning I don't own it anymore. And since I don't own it, I can't reference it here. Like I can't return it because that would be a possible memory leak or possible memory safety violation. That's sort of a weird thing about Rust if you're used to, I guess, almost any other language. I feel like this is unique to Rust, but the basic idea is if you I'm moving the data basically into the cache, and so I no longer have access to it. So those are the two reasons I think this will fail to compile. Let's see what the compile errors are to confirm. Yeah, so it was exactly those two. So the first error here, it's saying self.cache insert is going to mutate cache, but here I said self is not mutable, so that's one problem. And the other problem is here I moved red val into the cache, and so I cannot use the value anymore. So how do we fix this? So this one actually, it like the compiler is it's decent at trying to help you fix things. In this case, it says all you have to do is you have to say my function actually does mutate self, instead of by putting ampersand mute to mean mutable reference instead of the default which is immutable reference. So let's just make that change real quick here. Oh, we got a lot of compilers now, so let me scroll up a little bit. Man, I'm dreading this compiler actually, because this is the one that I think I got stuck on. Hopefully we'll be able to figure this one out. Oh, okay, I see the problem here. Or maybe I see one of the problems. So here this is line 8045. This is way down in the main method. Here, yeah, line 8045. And what it's saying is I'm invoking the stairs method, which declares that it's going to mutate. Sorry, wrong stairs method up here. It's going to mutate the instance, right? So this method is going to mutate this instance, but I declared this variable, this local variable, as immutable. So I'm just going to put mute here to say this is actually going to be a mutable instance, and so that should allow me to make this call here into stairs to mutate it. Okay, here line 43, 44. It's that I'm using the value red val after I moved it. So for that, the way I'm going to fix that for now is I'm just going to do the was it unimplemented? I can't even remember. And just to make that error go away temporarily, and we'll come back and we'll address that later. This is the one I was scared of. I didn't want to get this error because this is the one that I'm struggling to figure out how to fix. Can it borrow star self as mutable because self.cache is also borrowed as immutable? Immutable borrow happens here. 18. Man. This is the error I did not want to get, because this is where I got stumped for a long time. I could not figure out what to do. What is the problem? Cache was on some. I feel like this isn't gonna fix it, but I'm gonna try to implement a little scope to force the. Oh no, maybe what I did last time was it that I explicitly dropped the reference to convince the compiler that I'm not doing something shady here. What drop does is it explicitly causes this variable to no longer reference that object, meaning I'm releasing the borrow in a sense. Let's see if that helped any. Did it help? 1832. I feel like it did not help that much, or at all. 18 to 30. Immutable borrow occurs here. Mutable borrow occurs here. Dang. Do I need to do this pattern matching stuff? Check here. If let, maybe that's how to do it. Oh, that worked. Okay, I don't know what the difference is between what I did before and what I did now, in terms of type checking. I mean, I get that I changed a bunch of text, but in my mind, the two are doing, like at the borrow check level, the same thing. Let me go back to show you what the code was like before. We can compare them. It's like, where's redo? Redo is control Y. Okay. So what is this code doing? This code is saying, I'm gonna borrow self for a moment, immutably, and then I'm gonna get read from the cache field, which means I think that means I'm also borrowing that, and then I'm gonna call the get method, which doesn't mutate cache. So this is all an immutable borrow. When I do that, I'm going to get this, which is an option of reference of vec of usize, right? If you guys remember, let me write that down, or let me annotate it actually. It's an option of vec of usize. So what does that mean? The option, I don't want to get into options. If you don't know what option is, like you're probably gonna have to Google it, or maybe one day I'll make another video about a tutorial on option. But assuming you know what option is, the object inside of option is a reference to vec usize. Specifically, it's a reference to some value owned by the cache, right? So meaning this reference can only live as long as the cache lives, because if the cache gets deallocated, now this is going to reference deallocated memory, which is going to be a bug basically, or a memory leak. So what I'm doing here on the next line is I say, okay, is it the sum or is it the none, right? Like, and if it's a sum, then I want to get the value out. So after the unwrap, I now have my reference to vec usize, and now I'm going to make a clone of it, or a copy of it, which means I'm creating a new vec usize that just has the same data as the original vec usize, but it's a distinct object. I'm going to use the word object for lack of a better term. I don't know what REST would call it. In Java, we would call these objects. It's a distinct object, meaning it lives in a different memory location. So even if cache gets deallocated, and meaning the original vector gets deallocated, I still have my own personal copy of the vec, which isn't deallocated, and I can return that to the caller, and I'm passing ownership of it to the caller, so the caller is responsible for deallocating it, and they can do whatever they want with it. And then this was like a bandage thing to try to signal to the compiler that, and now I no longer need cache result. Like, cache result is never referenced any further in the code. And so the intent was that this cache result, which is an option of reference and so on, its lifetime cannot exceed that of the cache, right? Because this reference cannot exceed the lifetime of this cache. If the cache goes out of scope or gets deallocated, then this reference becomes garbage, which means this option object needs to not outlive the cache. We need to deallocate this option at least before we deallocate the cache. So I was hoping, like, the very first version of the code looked like this, and I was hoping the compiler could see, oh, so you're never referencing cache results anymore, so I can it's safe to deallocate here. Safe to deallocate cache results here. I was hoping the compiler would do that, but based on the compiler errors we saw, the compiler did not do that. So then I said, okay, what if I do explicitly? What if I say, at this point, I want to release cache result, I'm not using it anymore. But that still didn't work. We got the same compile error. So what I did instead is I did like this if let syntax, which is basically an if statement that does destructuring on pattern matching. So, and if you guys don't know what destructuring is, like for example in the context of Scala, does Kotlin have destructuring? I can't remember. I think if you Google for destructuring, especially in combination with option, the option monad, you'll see some tutorials on it. But the idea is, I want to create. I'm doing pattern matching here, meaning so what this if statement is saying is only execute the body of this if statement if the result of calling this method is a sum as opposed to a none, and furthermore within the body of this if statement, create a local variable called result whose value is whatever was inside the sum. So that's the destructuring part. The pattern matching part is this, where it's a sum if let sum, and then the destructuring part is the fact that I create a new local variable here, and that local variable is the reference to vec usize. So conceptually, like at the borrow level, I feel like this is providing the same information to the compiler. I'm borrowing the self and borrowing cache to invoke the get method on it, which returns an option, and if it's a sum, I'm going to take the reference to vec usize that I get back that's inside the sum, and I'm going to clone it to get my own vec usize. I'm going to return that. If it's not a sum, i.e. if it's a none, I'm just not going to do anything with it. We just proceed on. And the key thing here is that I'm not using the result of the get method beyond line 20, beyond this point, right? This is, at this point, save to deallocate the option return my get here. The compiler is happy at this point. It's satisfied. It says, yeah, I believe you that it's safe to deallocate here, and so no compiler error. So I don't understand why it thinks this one is safe and the other one isn't safe, because to me they seem the same. But here we are, right? Okay, so where was I? Right, so that was. So we addressed one problem here, which was if you guys recall, there was two compile errors. One is that we were trying to mutate self, but the method did not mark the self variable as mutatable, and the second was we tried to reference redval after we moved it, right? So here on the insert method takes ownership of the variable pointed to here, so meaning it took ownership of this vec that we created and that we've constructed here, so I can no longer reference redval at this point. So how do I? But I want to return that redval, right? So what do I do? What I'm going to do is I'm going to clone it. Actually, that wasn't originally what I was thinking of doing, but I just realized this is probably an easier solution. So here, I don't even know if this is going to work. We'll compile it and we'll find out. But my intent here is that rather than moving redval into the cache and letting the cache take ownership of redval, I'm going to create a copy of it and store that copy here. So now I am still the owner of redval, and I can return it. I think this will work. It seems like it'll work. Let's see. Yeah, I think that worked. So now what? The part that I'm confused about here is we're still seeing multiple calls, maybe? Why are we seeing multiple calls? 4, 3, 2, 1, 1, 2. So we save one guy. We're no longer doing this call. But what the heck? Why are there still these two calls? I'll try to understand that. I am super perplexed. Okay, what if I was trying to do my original idea, which was I was going to call self.cache.insert, and then I was just going to, now that we know that the value is in there, we can immediately call get to get the value out. That was what I was originally thinking of doing. Found reference. Oh yeah, and then we're gonna clone, not clone, but clone it. No, so that's not related to why this gets called multiple time. I don't understand why it's getting called multiple time. I'll have to think about that. So what's happening here? We're calling this with 4, which we're just going to call with 3, which is going to call with 2, which is going to call with 1. And then once that's done, we should have inserted this into the cache. So the cache should contain the results for calling it with 1. I'm gonna, I guess, comment this out. I'm worried, is there a spot where I'm accidentally calling this method when I meant, or this function when I intended to call this method? But that also means I'm gonna have to probably comment out this stuff. Nope, it's definitely calling this guy. But then why the heck is the cache not populating the way I expected it to be pop? Oh, you know what? I realized I put the print in the wrong location. I want the print to be here, right? So what's happening? Here's the mistake that I was making. I only want to say, like, I was called this was maybe not the best way to phrase it. I'm going to perform the computation for this input. If we're in this branch, meaning if we hit the cache, then it's not going to perform the computation, right? It's only if it gets to this point that it's going to actually perform this computation down here. So now I think this will show the output I expect, which is, yeah, 4, 3, 2, 1. So it only calls each computation once. I can uncomment this and uncomment this to get back the comparison between version 1 and version 2. Yep. So yeah, so there you have it. I think so this is the memoized version of the solution. Let me talk a little bit about some of the things I struggle with, like just as a when I was researching how to actually do the memoized version between the previous video and this video. My original, I think the thing that got me like completely on the wrong track and got me stuck for days and days was that I originally thought it would have been better to do this. And why? What does this mean? What my intention was, okay, so this cache owns the vec of usize, right? Meaning it's owning the vector, which so. But I always create a new copy. Like I'm doing all these clones everywhere, and so I thought if I just return a reference to the object in here, the caller could decide, do I want to clone it, or am I at the top level? Because the top level, when we get to the main function here, I actually don't need to clone the result that I get back, right? I'm just doing a read on it. I'm just going to print it out, and this result does indeed live as long or no longer than than this variable, the cache variable, right? Like the cache variable goes out of scope basically here. Save to deallocate cache stairs, and it would be safe to deallocate result right before that. So this is unsafe, right? This is unsafe if it were like this. Like if we deallocate cache stairs first, then now we have a reference to result, which in theory could have a reference to the vec that's stored inside of the cache. So, but if it's like this, then it's safe. And I was hoping the compiler could see that and all that. So that's why I said, okay, so we can be a little bit more, we can avoid a little bit of copying by having a reference here. But this actually made everything go wrong. And like, you know, because like this was going to give you these compile messages that point you in a certain direction. Am I wrong? Did I not save? I didn't save. It's going to say things like, oh yeah, you know, try doing this, or you this is supposed to be a reference, so try doing a borrow of this or whatever. Or like line 18 here as an example, this is a reference, so you don't need to clone it. You can just return the original reference you get back, and so on. But if you go down this route, you're gonna get into like this, or at least I did. I got into this huge nightmare of like crazy problems that are extremely hard to resolve. And what the core issue in the end, like it took me several days of research to figure this out. The core issue is that the cache can reallocate itself in a sense. So internally, if you're thinking of your like low level data structures class, you know, that you might have taken in university or something like that, to implement a hash map, what you would do is you would create like an array, I guess, right? Like let's say an array of 16 entries, or let's do 8, just so I don't have to type so much. You create an array of length 8, and then when someone gives you a key, this is your insert method, right? They give you a key and a value. What you would do, and let me put this in comments so that it's clear that this is pseudocode and I'm not doing Rust here. What you would do is you would take the key and you would hash it, right? So you get your hash code here. And then you would say, okay, so what bucket I'm going to put it in? I'm going to put it in the... I'm going to take the hash code, I'm going to take the modulus, or the remainder after dividing by 8, right? And then whether... And this is going to tell me, I guess this should be like 0 to 7 rather than 1 to 8. This would tell me which cell or which bucket to put it in, right? But like if the user starts inserting like lots of items, like basically more than 8 items, then it might make sense to reallocate a new array that goes to 16 basically, right? So there'd be like some if buckets too full, reallocate into bigger set of buckets, right? There's going to be some code that does this thing. So what it would do is you would create a new array, a new bigger array. You would do the new computation, right, which will give you different new hash code modulus computation, which would give you different bucket locations for all your existing entries that you're storing in your hash map. And then you would deallocate this, right? Because you don't need this anymore. You just have this thing. And that's where the problem happens. When you deallocate this, if someone else had references, like here, pointing to memory locations here, those would all be invalid now. And basically you'd be referencing the allocated memory. So that's basically like when you try to go down this path, you're gonna get all these crazy compile errors. And it doesn't tell you that that's the problem, but that, like, after you do some research, like this guy on Stack Overflow explained it pretty well. That's the core issue of why none of your borrows are going to check out. Like, the borrow checker is going to complain about what's going on. So yeah, so I think that's it for this video. Thanks for watching. I'll post a link to the code in the description. I don't know if I have it in me to do more rest. I might take a rest out of the video because like it is pretty hard for me, at least, to reason about some of these things. Ooh, let me get rid of it. Let's just make sure it compiles before I post the link to the code. Okay, yeah, so this version here, whatever this looks like right now, this is what I'm going to post in the link in the description. I don't think I'm good enough at Rust to do the more difficult problems. Like this interview problem was relatively easy conceptually, and so that's why I said, okay, let's try it in Rust. So maybe if I get another easy one, I might try that one in Rust, but I'm not confident in my Rust abilities, so I'm probably going to avoid it for the more difficult problems. It's a very interesting language. It's just there's a lot of oh yeah, that's something I want to mention. There's a lot of things which feels like it should have worked, or like the compiler should have figured out, and the compiler could not figure out. Like, this whole thing I was talking about earlier, where why does this version work where I do the let sum pattern matching, but the other version where I check, like I get the result out of the other, and I say, is it a sum? If so, return early, otherwise drop the reference. Why does that version not work? Because they're both doing the same thing. And there's there's an interesting, I don't know if I still have it. I think I closed the tab. I'll try to find the tab and I'll post a link. There's an interesting blog post which lists like a bunch of things that, a bunch of situations that feel like they should work but don't work, and also additionally they say like these are people, I guess people have been reporting these as bug reports to the people the developers of the Rust language, and the developers of the Rust language are actually trying to make changes. There's something called actually I can probably look for this, non-lexical Rust something NLL, non-lexical lifetimes. Yes. Yeah, so like they're saying they're going to add new features, new enhancements to the borrow checker. So I'll try to find that blog post and I'll put it in the link description. But I find if you guys are interested in Rust, I think that's a very interesting blog post to read, where it says here are things that feel like they should work but they don't currently work. And here's the progress report on how close the developers are to updating the borrow checker so that it will work. And so we saw an example of that here, right, where I had something where I said, well, I really feel like this should work, I don't know why it's not working, so I'm going to fiddle around with it until the compiler is happy. So yeah, that's the thing that so far I don't like about Rust is like all these fiddling with just to satisfy the compiler, because it really feels like like you're doing something that should be safe, but sometimes you're wrong. Like when I did the referencing here, I was like, this is perfectly reasonable, this should work, why isn't it working? And then on Stack Overflow, someone pointed out the whole issue where the cache can reallocate itself and thus move memory locations. So Rust is definitely would have catch bugs that I would not have thought about, like that memory allocation thing. This one I'm present here, I feel like it should have worked. Maybe I'm wrong. Maybe there is some sort of memory bug that I'm missing. But there are definitely some things that are correct programs, but the compiler or the type checker or the borrow checker doesn't realize are correct. And so the Rust developers are trying to improve that. So yeah, I think if you're interested in Rust, it'll be interesting to read. So yeah, thanks for watching, and I'll catch you guys next time.